Hey guys, Ray again. Last video you saw me put together the pellet extruder from Mahor Muniz. I'll put the link to this in the description of this video. I need to test it out. In order to do that, I gotta build another printer. Yeah, I know, it's a terrible thing to have another printer. So, I've got the Folgertech FT5 version 2 here that I'm gonna be putting together. And, most importantly, downloading the most current manual from their website. We'll take a look at all the major components as they go together and then hopefully be testing this thing out. So let's get started. Okay, so here are all the parts laid out nice and in the open, and there are a lot of parts. I'm lucky I have a nice workbench to work from, so I don't have to work on the floor. So here you can see the framing members. There's quite a few framing members here. These are the vertical legs. To give you an idea of the size of this printer, these legs are 700 millimeters in length, so it's going to be a nice sized printer. Taking a look at everything, that's the power supply. We have some small ACM parts. This is what aluminum composite material is. It's a layer of aluminum on each side with a polyethylene core. This is a material that's very commonly used in signage and building cladding, commercial building cladding. We have the belts and pulleys all right there. These here are the stepper motors. It comes with 5 stepper motors. I haven't bothered opening them just yet. Wiring harness, the extruder. I think this is the first thing that people do change on this printer, and it's fine. I mean, for the price of this printer, this extruder is fine. It's easily replaceable at a very low cost. Here we have more miscellaneous wiring. All of the ribbon cables and Caterpillar track there. This is the electronics board. Again, I'm not going to open that until I'm ready for it. In stops, heat sinks, all that is in there. LCD panel. There is the build plate. As you can see, it's 300 by 300 build plate. Came with this filament, which is really no good. I wouldn't even keep that. And then here are the main ACM panels that hold everything together. Here are the sliders. These are the rails. They're linear bearing rails. So there's 3 of them in there. 2 for the Y, 1 for the X. These are the lead screws and Thompson-like shafts. You can see they're polished shafts. That's for the Z-axis. A huge bag of hardware. Haven't opened this yet. I'm going to take it all out and organize it, but you can see everything listed on there. This is a massive bag of hardware. And then some more miscellaneous hardware, the feet, the ball nuts, etc. So that will be going together, and we'll take a look at the frame first. So I'm taking a moment to show you this. This tray that you see here is a drawer organizing tray from Harbor Freight, and I use this all the time to hold my hardware when I'm assembling anything whatsoever. And in this case, it came out perfect. I went ahead and emptied all the hardware. As you can see, there was quite a bit. I emptied out the 2 bags that I thought I was going to use right away, and I left everything else in their respective bags until I need them. So if you're going to be doing something like this, I recommend having something that will hold it and dispense it very easily. So let's get started. Alright, from time to time I keep running into parts that have this very sharp edge on it, and you can file that off or sand it down, but what I find works best is a straight utility blade, and you hold it at 90 degrees to that corner and just scratch it across there, and it takes that edge right off, and you can see how it exposes that aluminum. So that's what I've been doing just to knock the burr off of these parts. Works very good. The aluminum is thin enough where it doesn't make a difference. And just like that, it's not sharp anymore. Alright, there we have the base frame. This is what they call step 1. And I want to call attention to one little issue right here. Not a big deal. If you notice this rail, I'm going to set it right on top of the other rail, and I'm going to slide it back and forth. You hear that? This rail is a little bit loose in between the other rails. It turns out that this one was 0.5 millimeter shorter than the other. So what I did is I went through all of them and I found 2 that were exactly the same in order to help keep things square. Now it doesn't really matter that this is a half millimeter shorter. It's just that I'm very particular, and why not make the very bottom frame as square as possible. Here you can see that half millimeter difference. Alright, here we have another little problem. You will see that we've got these corner brackets here. There was a total of 13 of them, and if we take a look at them from their exterior dimensions, you will see that they're all pretty much the same on the exterior. So the overall size is the same, but if you look closely, none of these holes line up. Now, it doesn't really matter because they're used individually. However, this to me is a quality control issue. If I put a pin through here and I put a pin through here, it becomes a little bit more clear. So the holes and the hole patterns are in alignment, so that's good. But you'll notice that the exterior is all over the place. That means that the holes and the exterior of the parts do not line up. So this is a quality control problem. I suspect that they're cutting these on several different machines and they've got different programs. Things have changed, different versions of the files, and no one has caught on to the fact that they're different. So you can see here, considerably different. Now here, I have them in 3 piles because I have 3 of this one, 2 of this one, and the remaining number here. So I've got all these different versions. It's not going to change how to put this together. None of these line up, so it's not a big deal, but it is a quality control issue that I call into question. It's not hard to make all these parts the same, but they've somehow managed to make them 3 different ways. Now here, side by side, you can see the problem. This hole is very close to the edge, whereas this one is in a pretty good position. So 3 of the plates that I had were like this. I don't think it's going to matter. It's just that it gives you a little bit less surface for the bolt to attach to. So wish that were all the same, but it is what it is. Alright, so here I am after step 2. All 4 corners are in place, and it's actually surprisingly strong. If I pull on this corner, it will lift up the whole printer. So it's pretty stiff on the corner that has 2 corner brackets. The other ones have 1. I haven't gone that far ahead, but let's go on to step 3. Okay, we're just about done with this frame. This is the top of the frame, and I want to point out the problem with these brackets, these corner brackets being cut incorrectly is right here. You can see I built this on a flat surface, and look at the gap that's showing up. Now on the other side, on this side, you can see there's no gap, or very little gap, but look how much the gap is. And we'll flip it over and take a look at why that's happening, because we'll have to address that. Okay, so here you can see why quality is important. This right here is the top edge of those corner brackets. You can see they line up pretty good because I had them against the surface of the bench, of the top, so I had pretty good alignment. But because the holes are off from the exterior of the bracket, they don't line up properly with this 20 by 20 rail, and you can see the gap that it creates. Now I can straighten this out and line these all up straight, but then my bracket edges will be sticking up way beyond the top of the frame. So I'm going to have to do that, but that is, you know, a few points off for the bad craftsmanship here on the manufacturing of these corner brackets. This shouldn't happen. They should have a little bit more quality control for this. And here you can see the adjusted top. So I am flush on the corner, but this bracket is sticking out a good 3/16 of an inch. So there you go. That's what I'm going to have to live with. This is where we are after step 3. The next is step 4, where I install the intermediate rails using the intermediate brackets to hold that up. Hopefully these will go a little bit smoother than the brackets at the top. I'm a little disappointed in that. It's not going to alter the way it functions. It's just going to be a visual aesthetic, and I'm very particular, so I'm going to notice it all the time, at least until I do some modifications. Okay, so here it is at the completed frame stage. All in all, not bad. We already pointed out the problems. Everything is pretty sturdy. This frame is quite stiff and sturdy. I'm taking a look at it, and it's, you know, pretty strong, and it's not going to rack. So I'm very happy with the frame assembly. Let's continue with the Y assembly. Okay, here we are about halfway in the Y assembly and decided to show you this issue here. You'll notice that this block has a button head cap screw. It's 20 millimeters long, and this has a button head cap screw, and it is 16 millimeters long. They're both 4 millimeters. The instructions call for a, you can see right here, for a socket head cap screw in this bearing. The issue is that this is the only socket head cap screw, and you'll see this is a 5 millimeter and it's supposed to be a 4 millimeter here. The instructions are a beta version, version 1.1, so I suspect that the hardware kit has not been updated yet, and that is why these are button heads that are included instead of socket heads like the instructions are calling for. Okay, now's the interesting part. We're going to start with some of the stepper motors. It's time to put the pulleys on. Instructions say to make sure this shaft is sticking out 4 millimeters. So I'm going to set my verniers to 4 millimeter and set it right there. It's 4 millimeters. I'm going to snug that down. I'll do the same for the other side. Just double check that. Looks good. Alright, so I flipped it over and you can see this is that second rail, and there's that ACM panel that supports the bearings for the Z axis. Now we're going to install the stepper motor. Goes in back here, and the way they want it installed is like this. So at 45 degrees with the connector facing towards the back center. So we're going to go ahead and put that in there. Alright, now we just got to repeat it for the other side. Okay, so here's where things get a little bit more interesting. There's the installed stepper motor. Down here is the idler pulley. Now here is why it's tricky. The way they want you to assemble it according to the instructions is you have the M5 by 25 millimeter screw, goes through the idler pulley, then this M5 nut, it goes through the ACM, and then a lock nut goes on the other side. So here's the problem. If you are not careful, you can very easily over tighten this. As you're tightening, this nut will tighten on the screw, bind the bearings, and then it won't spin at all. Just be cautious you don't over tighten this. Make sure it turns. It's got to be snug where it's not loose. The whole screw itself is not loose, but that it will still rotate. Alright, I'm getting ready to set the first rail. I've gone ahead and pre-assembled the left side, and the pre-assembly includes these two pieces of ACM on the rail. Well, if you've noticed right here, I left these cable ties on the ends while I was doing all the assembly, because you don't want this sliding off the end. I've had it happen before in other projects. The bearings in there will fall out and it'll be a huge mess, and chances to get it back together are very slim. So I did all the assembly. I'm going to cut these off now. I'm going to make sure they're all facing lengthwise. Make life a lot easier. I'm going to set it right here in this track. There we are. The next thing I'm going to do is to make sure this is centered. You can see it's centered here. I'm going to measure from the end of this rail to the inside faces here, just so I can make sure it's centered in this direction. So I'm going to measure that, and then I'm going to snug them all down. Okay, so here's where we are. We've got the Y rails on both sides installed. Looks good. Now here's where things get a little weird with the instructions. We are to remove this rail, which means we've got these screws, and the 4 more that are under here to remove this rail in order to fit the belt. It's kind of weird. I'm not sure why this sequence of events are outlined this way, but we're going to go ahead and do that. Take this rail off and put the belt on. Alright, I've loosened up all the screws, and I'm just going to take this off. It's not a big deal. I mean, you can see why you have to remove it, because there's the motor pulley, and here is the idler pulley, in order to put the belt in and then attach it to the y-axis carriage. It just seems that it probably could have been thought of a little bit easier than having to put something on and then take it off. But it makes sense as to why. We got to do this to both sides. I'm going to do one side at a time and then do the other. Okay, so I've went ahead and installed the belt, and you can see it's a little bit slack right there. I'm just going to go ahead and pull the motor snugly as it recommends in the instructions, and I'm going to snug down its position with the belt tight. The belt is tight. There's really no recommendation for how tight is tight enough, but you can see I've already done this side. It recommends to use the provided zip ties. So when I did that, and I'm just going to trim them here with a pair of shears. And there's a slot in the bottom of this plate, and I'm just going to reach up under here and trim the excess belt so it doesn't interfere with my pulleys. So now if we move it, I can see my motor turning all the way to there. This goes to here, and I can see that this pulley is turning. Remember, this is the one that you can easily over tighten, so I just wanted to double check that. That looks good. And if I pull the belt, that is working the way it's supposed to. So now I'm going to put this rail back on. So I'm in the vertical tracks first, and I'm going to bring it down. All our T-nuts are in. Alright, I'm going to go ahead and tighten it all up and then do the same on the other side. So the next step calls for this little bracket with the in-stop right there attached to this frame. Now it says to put it all the way in the back corner. Now I haven't read far enough in the instructions to find out if they remedy this, but I can tell you that when this goes all the way down, it will not hit this in-stop. So theoretically this should be about here, further away than in the corner. I'm going to keep an eye on that because I don't know if in the instructions this is adjusted further out, but for right now it says put it in the corner, and it will not be far enough. The other thing is that I can see from the position of the pulley and the in-stop and everything together, it's a good thing I had the zip ties very, very close to the bracket, as you can see on this side, because this will go right into that pulley. If it's too long, you're going to reduce the amount of travel you have in the y-axis. So I just wanted to call attention to that. I'm going to just put this in the back corner. I'm not going to tighten it because I have a feeling it needs to be adjusted when everything is in place. So I went ahead and assembled the Hotend, and you can see something very peculiar. If you look carefully, the distance between here and here and the other side, you can actually see that it's a little bit of an angle. Something is not right here. Now I suspect these components are just straight from China, and no one has bothered to look at them. So we are 0 here, and if I measure this side, I get 798. If I measure the other side, I get 824. So you can see there is a significant difference. There's 0.26 millimeters difference there. So it's not my imagination. It is actually at an angle. A little bit of QC. Again, I think these came straight from China. No one's bothered to check them. So that's the issue there. The other issue is right here on the heatsink. So this fan will get mounted through here, and we'll get some long screws that go through all the assembly and attaches to the motor. The problem, if you look carefully, is I don't have holes. I'm missing the 2 holes in my part here and here. So, and you can see that on the other side they're missing. So I'm gonna have to put those holes in. For me, it's not a problem. I'll drill them. Not a big deal. But again, it's another quality control issue. So you see a lot of these little quality control problems showing up. So I'm going to go ahead and drill those holes, and then we'll get back to assembly. Okay, so I figured I'd show you this right now. There's the heatsink, and you can see I've already started. I got two little dimples in there, and I almost went ahead and drilled it. I figured somebody might find this useful. What I did is I just lined this up and held it very firmly. This does not have to be complicated. Aluminum is very soft. Lined it up so it's very, very square. And I got my drill bit in here, and all I did was just go down and use the fan as a guide. Right in those holes, and that is how I ended up with those two little dimples. Now I'll just finish by clamping this down right here to my workbench. Now we'll just finish drilling these holes. And there are the holes. And just to make sure everything lines up, I'm going to put the fan on here. And that lines up perfectly. You can see the holes there in the camera. And that's how we're going to continue. The instructions call for disassembling the extruder assembly. I'm going to do that here. There we go, we got it disassembled. And the nut that was holding it together is only for shipping purposes, so we won't need that. Then it calls for attaching the extruder gear, which we'll do here, and to set it at 9.5 millimeters. So I'm going to do that. 9.5 millimeters is right there. I'm going to go ahead and button this up. We want the wire plug facing to the left. This portion goes on like so. There's that. And now the same screw that came out goes back in. Okay, so I've already assembled this a few times and ran into one issue after another. So what I'm going to just do is summarize that for you. If you try to assemble this as they have it called out, what you'll find is that the head of these screws are just a little bit too big to fit in there, and they are otherwise too short to reach, so they need to be all the way down. The heads are 5.62 millimeters, and I have a 6 millimeter drill right here, so I'm just going to open this up a little bit just so it will accept, and you can see I'm just doing it by hand. I'm just cleaning that hole up. I don't want to use a drill because I don't want to overdo it. So I'm just opening it up by hand. I'll do the other side. By doing it by hand, you can see it's only a slight difference. That's it. That's all it takes. And now what you'll find is that the head of the screw will go down in there. So I would recommend do that, otherwise it's not long enough to go all the way down. So now to do the assembly, I know that I want to finish in this position. I'm going to go ahead and put these screws in first. Then I'm going to flip it upside down. The next thing would be the 12 millimeter spacers, the heat sink. And by the way, I tested this on a 12 volt battery just to make sure I had the orientation correct. So it does go this way. The heat sink, then the upper block, and the Hotend assembly. Now what you'll notice here is that the screws are pushing their way down, and that's okay. Just going to put my fingers in there to hold them up. There are the washers. And now I'm going to take this and put it right on top, the motor. And that just lines it up for me. So now I've got everything together in a sandwich that's not going to fall apart on me. Like that. Nice and simple and easy. Only because I've had this thing apart now a few times. There it is, the whole extruder assembly. All the wires are hanging on one side. And that's what they want you to do. Okay, so here's where I am with the printer. I went ahead and installed the X-axis rail. It was very simple. We have the T-nuts and the 5mm screws that we put on here before on both sides. They lined up pretty nice. The instructions say to make sure that the distance to the front is the same on both sides. And what I did to make sure that was the case is I used the front panel. I laid it here against the rail, brought it in, came over to the other side, did the same thing, and you can see that they're the same. So then went ahead and snugged up the rail. The instructions say to use this access hole to snug up the screw, but I found that using the inside was just as easy, and then come back and snug up the outside one. I will tell you that this rail is barely long enough to catch those last screws on each end, so you got to make sure you have it centered. The other thing that I did is this ended up feeling a little bit too tight. It feels nice now, but it felt too tight, and I went through and loosened up all the screws on the left hand side that hold the linear rail in place. I positioned it to the front, snugged down the front one, positioned it to the back, snugged down the back one, positioned in the middle, snugged down the middle, and then went ahead and snugged all the rest of them down. And what that does is it makes the left side parallel to the right side, so that there wouldn't be any binding between the two sides. So it feels pretty smooth. There's really no play between the sides. It feels very good to me. So the next thing would be to attach the linear guide rail on top of this piece of 2020. Again, I'm going to make it centered, but it's pretty straightforward. You can read the instructions on that. Okay, I wanted to take a moment to show you something I found out while I was doing some of these test moves here. And I will call attention to this pulley. You see this pulley that goes on the extruder motor. So that's the timing pulley that engages the belt. Watch this very carefully as I maneuver the rail. Do you see the wobble? See how that pulley is wobbling? I'll do it slowly so you can see it better. That pulley is actually wobbling considerably. Let's look a little closer. There you can see how much wobble is in that pulley. Now, this is another quality control problem. These are probably made in China for less than about $1 a piece, and the quality shows. I don't think anyone has stopped to take a look at this. I'm going to leave it in here, and the reason I'm going to leave it in here is because I'm going to treat this as if I were a regular person, not somebody who runs a machine shop that is aware of mechanical properties here. So just an average person assembling this, and I'm going to leave this, but I'm going to keep it in the back of my mind in the event that I do have a problem and this wobble turns out to be an issue. I really don't think that in this particular application that amount of wobble is going to add up to any inconsistencies or lack of accuracy. But I wanted you to see that you may have this same exact problem because of this low quality pulley. Let's take a look at why this pulley is wobbling, and then it'll make sense what's happening. Okay, so there are two different sizes. You can see that these are the timing pulleys, and they're two different sizes. So it's interesting why they're two different sizes, because otherwise they're the same, and that makes a lot of sense. So if we take a close look, this one here is just over 8 millimeters. This one here is just over 5. If you look really, really closely, you will notice that there is a hairline right on the outside there. That hairline is approximately 10 millimeters. Yeah, that's approximately 10 millimeter hairline. Now, obviously, I can't measure that carefully. If you look at this pulley, it also has the same hairline. It's actually more obvious here. That hairline is, guess what? Also 10 millimeters. That tells me that these are both the same pulley. They're probably make them by the millions, the same exact pulley. The difference is that when they need a different size, they put a bushing in it. So they bush these pulleys to make the shaft diameter correspond to what the customer wants. Well, this inserts a possibility for a lack of accuracy, because that bushing can be made inaccurately. And if we take a look, so this wall to edge is 556, this wall to edge is 545, so there is a 0.1 millimeter difference. That's just on this one. So they've bushed these to fit their needs, and I think that maybe the bushings are a little bit less accurate than the pulleys themselves, which would mean that it may wobble, and that's what we see. So I don't know if it's all of them. The left side of the printer seems fine. It's only showing up on the right side of the printer. So I think I'm just going to live with it, and if it's a problem, I can replace these with better quality ones. The next step is just to go ahead and put together the Z-axis motor. We've got the pulley, that it is 1 millimeter from the end of the shaft. We've got this piece of ACM, the screws to attach it, and then of course these 5 millimeter screws with the T-nuts. Straightforward. Let's finish the assembly. So here things get a little bit unexpected, I would say. We need to mount this limit switch right here, these end stop, upside down. Now it's unusual because the other ones have provisions to mount it the other way, but we'll have to mount this one upside down. And we need to pull out these two screws. I'm just going to go ahead and pull them out now. Now it's tricky because you can see that the only thing supporting this and keeping it straight is the body of the switch. Really has no other support, so you got to be very careful you do not over tighten this, because you can probably break that circuit board. The part that goes up here is this piece. Now I'm assuming this will become obvious later on, but for right now that goes there with the 40 millimeter screws provided in the kit. Go ahead and assemble those. Alright, so I got the whole thing assembled and I ran into a problem. The problem was that this screw would not go in all the way into the motor. So when I flipped it over, I discovered that this screw that you see right here was actually in the way. So if you try to tighten the screw, it won't do anything. So that this screw you cannot put in. The instructions call for 3 of these, but you can't have this one and this one in the same motor on the same side. So I've removed it from this side, because I think you really need to have at least 2 on here, and having 2 on this side should be enough, hopefully. Another little issue there, I think it'll be fine, but if you run into this problem, I just removed that. Alright, so here we have the X-axis assembly in place. There are 2 things that the instructions are not clear about. One, it says to get this mounted with this bottom plate in contact against the end of this rail. What it does not mention, and it's the problem that I had, is that the leading edge of this plate will hit this first. You have to adjust your rail so that the end of the rail is in the notch. So there's a notch on this plate, and that's where you want your end rail to hit, not on the edge, which it may catch on. So that's a little clarification. I ended up looking further down in the instruction manual and found a good photograph of this that showed it in this way. The second thing is that these are the 2 5 millimeter screws that hold this assembly to the 20 by 20 rail. You cannot really access this comfortably, this screw here. I took off the top plate that's attached to the motor, tightened this down, and then returned the top plate. I don't know why they have you mount this plate first when clearly you should have access to these screws to attach it and then put the plate on top. So it does not make sense, but that's how I had to do it, and if you have that problem, that's how you fix it. Here we have the rail in place that you saw earlier, and I went ahead and installed the idler. It's very similar to the previous idler, very straightforward. Just make sure that it still rotates. You don't want that locking up. And then the ACM pad on the linear bearing. Now again, be careful you don't slide it off the end. So that's in place now. Alright, the next step is to finish up the X-Carriage by mounting the remaining ACM parts and putting the extruder on. But there is an issue. if you look real close, you'll see that this opening in the corners has little rounded areas where they pre-drill the holes to relieve the corner. What that does is, if you insert, you can see these corners are square. If you insert this part in here, it will go in and the corners are clear, as you can see there. But down here, they failed to do the very same thing. So you can see that these corners are radiused. Well, that will prevent this from actually fitting. You see, it will not fit in there. We have two possible solutions. One is you take and file these corners so they're round and then they'll fit in there. Or two, we're going to take this over to the scroll saw and I'll show you how I fix this. So this is the scroll saw, and here are the parts we're going to fix. Again, you can see how these holes are radiused, and you can see these holes have relief, little relief holes. So I'm just going to open up these corners here so we have the same relief. So this little piece, I forget which number it is, has the same issue. You see that the corner has a radius in it. We need to relieve that corner. If you don't relieve it, you end up with a part that will not seat correctly. You can see here. See how it wants to rock. It doesn't seat correctly because the radiuses are in the way. So we'll fix this and then we'll come and take a look at what it does afterwards. Okay, so now that I've modified that piece, if I put it in here, you'll notice it's nice and tight. Real nice tight joint there. You can see it on this side. It's a good fit. Very tight. It doesn't want to rock. It's perfect. That's what you want. This is why I use the scroll saw instead of just filing it, because you got to do the inside corners on a few of these. And here are all the parts in the carriage assembled. Right there on the other side were the holes that I had to open up. But looks like it's doing pretty good. Now let's get the extruder mounted. I decided to show you how I added the X belt because the Y belts were in a very tough spot. It was hard to see, but this one's out in the open. The first thing I do is I just give it just a little bit of a bend in here so that I can slip it in behind here and pull it through like so. And the instructions kind of show you all this, but not in detail, so you have to figure it out yourself. Then you just have to put in a zip tie, making sure the teeth of the belt are engaged with each other. Now I've only got an inch or two because I'm going to cut off the extra. I'm going to put this on here as close as possible, nice and tight, but without distorting the belt. I want to make sure that belt is still straight and flat, but you want this tight. If you pull too tight, you'll distort it. So that's 1, 2 for extra security. And I've got them about a 1/4 inch apart. They're very close together. Then I'm just going to trim the tails. And the same for the belt. And the reason I don't want too much hanging off is because in this case it doesn't matter, but on the y-axis these will interfere with the pulley, but in this case it didn't matter. So now I'm just going to go around and do the same to the other side. And here we are with the belt installed on the X-Carriage. Looks good. Alright, the Z-plate is assembled. The instructions are straightforward. I will tell you though, the spacing for the tooth pulley on the stepper motor is not included in the instructions. However, because this thickness is the same as everywhere else, that measurement is 4 millimeters. So that's not a problem. You can find that if you look further down in the instructions. We've got the idler pulleys. We've got the little fan motor. I've got the bearings and the rod blocks, as well as all the T-nuts are already installed. So now we just have to put it in the frame of the printer. I know through the magic of editing that looked easy, but that took a couple of minutes. Just going to go through, and what I find works really well for this is if you loosen the screws a little bit to make sure you're bottomed all the way out, those T-nuts should turn as they tighten up. I'm going to work from the center outwards so I don't create a wrinkle. If you work from the outside in or from one side and go all the way around, you might end up creating a wrinkle in this material. It may not seem like it, but you can in fact create stress in the material. So I'm just going to work from the center out to the corners from each side. Okay, the base plate is in place, nice and tight, and the build plate support panel has been assembled with the linear bearings and the lead screw nuts. All that is in place. There's quite a few screws here, so be prepared for doing quite a bit of wrench turning. Now it's starting to look like a printer, at least very close to one. That fits in there beautifully. That's looking pretty good now. We've got a little bit more work to do, and we can start the electronics. Up next, we'll put in the rods and lead screws. So I'm at the point of the build where I'm putting in the linear rods, as you can see here, with the lead screws. And I followed the instructions completely. There is a little bit of a problem, and that was that I could not get everything else to line up correctly with this first rod set to perpendicular in both directions as is shown in the instruction manual. The problem, we'll take a look, is that the entire frame was out of rack. So you'll see I loosened these corner brackets. They're just loose on both the front and the back, and I'm going to show you how far out of rack it is. I've already straightened out this side, but the back side is still way out of rack. And what I'm doing is I'm just loosening these up, bringing it back into rack, and then I'm going to tighten them down so it shouldn't affect the location of anything else. And I'm only doing it a little bit at a time. Now the bottom, or I should say the left side, what is the bottom in this position, is actually pretty square, but the right side is out of rack. So when I'm done doing the front and back, I'm going to do the right side and straighten it back up, and then we'll go ahead and finish this up. Okay, so as I said before, you can see these corner brackets are loose, and loosening this side was enough to release the tension in the frame and tighten it up, and you will see that that frame is just about perfectly square at this position. When we look at the back side, you will notice it is about 1/8 of an inch off over 12 inches. You can see it right there. It is significant. So I'm going to go ahead and finish straightening this out. And now I just got to tighten this side. Okay, I finished putting in the bed support. Everything is in alignment fairly well after I re-squared the frame. But I'm having a little bit of an issue. So if you look at, this is a straight edge here. If you look at the straight edge, you will see that the plate that supports the bed is actually not flat, and in this direction it's almost 3/16 of an inch. The other direction, you can see at the center, there is about at least 1/16 of an inch gap, maybe a little bit more. So the bed has a shadow dish in it this way, and it has a crown in it front to back. So a dish left to right and a crown front to back. What that's doing is at the corners where the linear bearings are, all four corners, they're actually being pulled at an angle. They won't line up straight. Now I will cycle this up and down a little bit, and you can see where it's actually binding. Now when everything was loose, I had it going up and down relatively easily, but now that everything's locked in place, it is actually very stiff. Now, is it going to be enough to be a problem? I don't think it will be, but I wish it was flatter and straighter, and I might have to replace this plate with something that is much flatter and straighter, or introduce some reinforcement frames in both directions to help flatten it out. The base plate, the bottom plate that supports the Z-axis motor, had a similar shape to it, but because it has a frame all the way around the outside, it flattened it out tremendously. I might need to do the same thing with this bed support plate. Alright, here you can see that I've got the bed in place. That was quite straightforward, nothing complicated there. The next thing I'm going to do now is work on the cable trays that go from here to here and from here down to here for the XY axes. There's some cable trays. One thing I will tell you is that the instructions call to attach this bracket now. The problem, of course, is that you've got just a tiny little space here. So do yourself a favor and put that bracket on there first before putting all this together. So that's going to be a bit of a pain to try to put it in now. I wanted to show you where I am here in the build. We've got the belt in place with the rods, the lead screws. You can see there turning very nicely, and it's moving the bed up and down as expected. Getting everything lined up was a big payoff because it's pretty smooth. It's not perfect, but it's quite smooth right now. I've just got the cable trays, as you, sorry, the cable chain. I call them cable trays. It's the same thing. Cable chain, cable tray. To attach them, I've got them here on the x-axis, and then here and here on the y-axis. 1, 2, and 3 locations are easy to attach, no problem there. This one right here is a bit problematic. If you notice, this is the linear rail, so there is very little space here. So if I had to do this again, what I would do is attach this piece of the cable chain before assembling the whole extruder mount assembly. Would be a whole lot easier. It's not impossible, as you see I got it done, but it's definitely not simple, and it wasn't that easy. But yeah, it is possible to do, so you shouldn't shy away if you want to follow the instructions. But the cable trays are nice. The cable chain is very nice little feature. I like it, so it's going to keep the cable management in order. Alright, so here we have the Z in-stop that I installed, and it's also where the instructions get a little wonky. It says to use 20mm long M3 bolts to attach the micro switch. Well, this is how long a 20mm M3 screw is. It's effectively twice as long as it needs to be. So the instructions are starting to get a little weird. I went ahead and put some 10mm ones in here instead of these 20s because it's just ridiculously long. So similarly, we're getting some weird directions here as well. So this is the MKS control board, and it says to put here 12mm screws. Well, I will tell you that through this entire thickness, 12mm is not enough. I had to use 18mm screws. It also says to use a 5mm nylon spacer, which is what you see in there. Well, there are no 5mm nylon spacers included in the kit. Instead are these little polyethylene spacers, I believe what they are, and as you can see, they're 6mm. Now if you look at it, the color is a little bit different. This here looks more like nylon than this. This looks like polyethylene, this looks like nylon. There are no 5mm nylon spacers included, but the 6 is just about right, and you just needed a longer screw to attach the board. As you can see, we are in the home stretch now, putting in the rear electronics compartment. It's looking good, but again, there's a little weirdness in the instructions, so I'm going to show you with these two remaining panels. So if I attach these, and these actually will fit together like this, is how they will end up. The instructions say to use a 20mm screw to attach these. Well, you can see what happens when you use a 20mm screw. It's too long. You really need a 16mm screw, which is what this one is. So I'm going to ignore what they say about the 20mm, and I'm going to use 16 to finish this enclosure. Alright, we have finished the assembly of the electronic enclosure. We got the board in, the power supply. On this side we've got the USB cable mount, and on the opposite side the plug-in. Now I'm just going to go ahead and put the LCD panel in the front, and we can begin wiring. Here we are with the assembly of the basic machine complete, with wiring still left to do. We are taken to page 64 of the manual to the LCD screen. Wiring is about another 13 or so pages. I'm just going to go ahead and do all the wiring unless I run into something unusual. I'm just going to follow the instructions. Well, we are at the wiring stage, and you can see I've gotten my wires all loomed up together. What I did is I went ahead and marked these as X, as you can see there, and this one here is the extruder, because when you've got these all bundled in together, if you're not paying attention, it's easy to mix them up. So I went ahead and marked them. I've also kept them bundled up separately, as you can see, nice and separate, make things a little bit easier. The instructions call for this wire loom, and I had a hell of a time, so I'm not going to put that on. Anything that's exposed afterwards, I will put on a hard plastic loom on, so that's not going to be an issue. But what I did do is take the shrink wrap, or I'm sorry, the shrink tubing, heat shrink tubing, and cut them into rings and slip it on there to help control these wires. So I've got them periodically spaced, and then I've got these last pieces here, and of course that is the part that's going to go to the extruder head. Now I went ahead and also did the Y wiring for the Y axis. It was a little bit funny in the instructions, but I just laid them out, measured them, and then cut them. So here you can see this is going to be the right hand motor, and then down here this is the left hand motor. They're both for the Ys, and I've also marked them left and right so I wouldn't get them confused. And the wiring for the block was actually straightforward, but I left this pigtail long. I went ahead and did a little bit of the wiring already on the machine. I've got my Z and Y axis in-stop wires already in. Nothing's hooked up yet, except right here I've got the Z axis motor, which is there. It was easier just to go ahead and run the wiring for that underneath because it took a while. But I'm going to run all the wires in, and again I've got my connectors marked. So that's the Z-axis in-stop, and that's the Y-axis in-stop. So I don't have to trace them back. I know which ones they are, and they'll be able to plug it in. So I'm going to go ahead and lay the wires. Also, I went and disconnected the wire track. Went ahead and disconnected that and opened up all the doors just to make life easier. Did it for both axes, X and Z. I'm sorry. I went ahead and did it for both axes, X and Y, so I can fish my wires through a lot easier. I think this part's going to be pretty straightforward, so we'll come back after it's wired. Alright, exciting times. I went ahead and got Marlin loaded up, no problems at all. Went right in, it was smooth. I didn't think it was going to be that easy, but it was smooth. I've got Repetier host on my laptop, and as you can see, everything is up and running. It was smooth. I cannot tell you how smooth and easy this was, and I'm about to home it for the first time. We're going to check it out. Homing the X. The Z dropped a little bit, now it's homing X. Everything looks good. It's home Y. I can see that it's reading perfect, 0. And now Z. I hear a little vibration somewhere. I'm not sure where that is, but it's not a big deal. That home Z perfectly. It looks like XYZ 0. I did check the bed level before I turned it on, and it looks like I'm good, right where I left it. So now we've got to, according to the instructions, test out the heat bed and the extruder nozzle. So let's do that next. I've set the extruder to 200 degrees. Let's start it. Heating failed. Printer halted. Please reset. Fatal error on the printer side. Stop the printer until the printer error is fixed. Heating failed. System stopped. Okay, let's try that again. I had a little problem with the extruder heater, and now the extruder is working. Temperature is rising very quickly. It's actually rising faster than I can measure it on the outside. It came up rather quickly. 196, 196.22, so 197. So it's looking pretty good there. And let's turn on the heat bed. Heat bed is currently at 25 degrees. We'll double check that. 25 degrees. I've already installed my glass top on here. I told you I like to do that, so the glass is on there already. $25, $28, $29. So it usually takes a little while for the heat to get up through the glass. Heater's working good. I'm going to shut it down. Shut off the heater while we are waiting on the heat bed. $36. So the heat bed is definitely rising. $36. We're looking good. $36. Excellent. $46. $46. That heat bed is warming up pretty quickly. And on the surface here, we're at 44. So there is, and that's 48. There's a 4-degree difference between the bottom of the heat bed and the glass surface while it's warming up. I think when it reaches temperature, it'll equalize. I've never had an issue with the bed warming using glass. I prefer glass. And I think we are ready for the first print. I'm very excited. If you can't tell, this is my excited face. Yeah, I'm very excited about trying the first print out, and I'm probably only going to get one print on this with the existing setup. First print on this is a little sword. It's a small part, yes, but I wanted to test it, you know, corner to corner to see how it would print, and it did so flawlessly. This is a flawless print. It looks great. My nephew's visiting me and he said, oh, can you make me a sword? And this is a perfect opportunity. So I'm going to take it off. We'll take a closer look and then we'll print something taller. Alright, well, unfortunately I lost the footage of the time lapse for printing this thing, but let's take it off. There we go. It is a Weeping Angel. Took about 8 hours and it's 300 millimeters tall. I used a 1mm nozzle. I want to see if the Folgertech FT5 could handle using a 1mm nozzle, and I had the height set to 0.4 millimeters. Now, there are some defects in here, because that was my settings with retraction and coasting. This was the first modeled straight out of slicing. I didn't check anything. I just went ahead and ran it. So it still needs to be done. But at a 1mm single wall, this is only one wall with 10% infill. And this is super hard, which is why I wanted a larger printer to print big things fast. With a 0.4mm nozzle, this would have taken about 30 hours to do this at this height. And of course I had to have finer layers. These defects are really just as a result of my own settings in the slicer. But all in all, I don't see any stringing because it under extruded at the layer transition points. So I'm not surprised there. But not bad. For a test print, I think that came out pretty good though. The hands and the fingers are strong. No support material, so as a result, take a look. There you can see the defects, and right here, since there was no support, the fingers are a little bit loose. You can see in the back side some of the defects there. But remember, 1mm nozzle, 8 hours of printing, 300 millimeters tall. It's pretty darn heavy. I think it's about 300 to 400 grams. Wow, that's pretty hard there. So after only these first two prints, this is all I printed on the Folgertech. I'm satisfied with it. Now it's time to modify the printer for the pellet extruder. You probably saw this in my previous video. Again, I'll put a link to this in the upper right and in the description of the video so you can check that out. 5 pounds of HDPE. I was able to get 5 pounds of HDPE pellets for the pellet extruder. So I have something to start off with printing and see how it goes with this pellet extruder. So in closing, the Folgertech FT5 3D printer. There were a few issues which you saw in the video. Some QC problems which I thought were at this stage in their production kind of weird to have. I don't know why they would have so many QC problems since they've been producing this 3D printer for years now. Several years it's been available. There are many of them out there. So it's a little bit funny. The fact that these are uneven, they aesthetically bothers me. And you can't see it from that angle, but these corner brackets are a little bit uneven because they're slightly different. They're slightly different. Now, those of you who've been watching my channel know that I run a machine shop. So, making things the same is not hard. It's not a hard thing to do. Why they have failed to make it the same here is a bit of a mystery. The bed plate, as you saw, it had cupping into it, so it kind of has a little bit of warpage. It's borderline. I wouldn't want any more. It would be a problem, but it's borderline. Again, that is a QC problem. They should have identified that during the assembly of the package for shipping. Somebody missed the boat on that. First mod I did obviously was use the glass plate. I didn't use the build surface. I've never tried this. I just didn't want to bother with something new and have to figure it all out. I know glass works great for me and I love it. So that was, as you saw, this thing printed no problem. And you can see the bottom. Love using glass. Bottoms are always nice. Sticks well and releases well. I mean, why try something when you've got a good thing going? So, is the Folgertech worth the money even after those little QC problems? For the size, I think it's absolutely worth the money. For me, on and off, it took about a month to put this together because I couldn't concentrate on it every single day. So over the course of about a month I put it together. Only had that one little small hiccup. That was a firmware issue. Quickly someone responded to my request on the Facebook Folgertech Facebook page, and within a day they had the new firmware uploaded, and I was able to go ahead and upload it to this. It was a valuable experience. This is the first time I put together a kit 3D printer, and I really enjoy the fact that it is 100% DIY, including knowing how to load the firmware, which I've never done before. Everything was documented good enough in the instruction manual, the one that I was using, version 1.15. I believe there's a updated version that came out not too long ago, right after this one. So I haven't seen that instruction manual. It might be slightly different than the one I used. But I think it's absolutely worth the money, even with those issues. Had no problems once we started printing and once we worked out that firmware issue. Everything worked perfectly right out the gate. This was the very first thing I printed on it, and this was the very second thing I printed on it, obviously with a few modifications, including the nozzle. I wanted to see if the extruder and the Hotend had enough power to actually use a 1mm nozzle, and it did. So I'm going to probably move up to a 1.2mm nozzle and not worry too much about it. I'm using this as a test bed for this pellet extruder only because I'm curious about pellet extrusion, and I think that for the next printer, which is going to be a home built, well, a shop built 3D printer of significant volume, it'll be measured in feet and not millimeters, so several feet in all directions, that we'll probably have to use a beefier version of this. I want to lay down 3 to 5 kilograms an hour. That's how much material I want to lay down. And if you think that sounds crazy, there are printers that can lay up to 150 kilograms an hour. So I think 3 to 5 kilograms an hour is not unreasonable. So if you made it this far, I'd like to thank you all for watching. Please don't forget to like, comment, share, and subscribe. If you have any questions, put them in the comments. I do read all of the comments and I will respond. I'll put links to all the things that we've talked about in the description of this video. And I'll also put links to my other 3D printing videos in the event that you're curious. There will be at least a couple more 3D printer videos coming, along with my regular kind of content. Again, thank you all for watching. Please don't forget to like, comment, share, and subscribe. See you next time.